Episode 233. Welcome to Data Skeptic, a podcast about data science and fake news from an algorithmic perspective. Here's your host, Kyle Polich.
Coming to you from Grand Rapids, Michigan, the first show entirely hosted by a text-to-speech algorithm. This is Data Skeptic. Today we're going to be discussing a piece of software called Deep Fakes. The deep, of course, alludes to deep learning, and the fakes part describes the function of the software. It maps one person's face onto another person's body. Now, I've put a few links in the show notes you might want to check out. They're all safe for work, and they demonstrate this. And as you will see, and as we'll discuss in the interview, a human inspector can pretty quickly tell these are fakes. That's by today's technology anyway. But if you'll indulge me, I'd like to speculate a few years down the road. Maybe a decade, could be more. But at some point, in this battle of generator versus discriminator, the generator will win, with certainty. There will come a day when algorithms generate videos that are indistinguishable from real videos. Right now, instead of recording this introduction, I could go out into the Grand Rapids nightlife and do something deeply irresponsible. That act could be videotaped and uploaded to YouTube, or maybe it wouldn't be allowed on YouTube. Now, that's not going to happen, but it could. The laws of physics don't prevent it. And if it were videotaped, that videotape would exist. There's some configuration of bits on disk that when decoded and turned into video would produce a convincing, in that scenario, real video. And we have no reason to suspect that there won't be an algorithm that can one day compute exactly that ordering of bits, or at least, one close enough within the manifold of videos that seem consistent with reality. We're not there yet, of course. I mean, did you see what they did to Carrie Fisher? That was a little creepy, right? And there's going to be a lot more creepy stuff in the future. But I'm putting you guys on notice, okay? You're my data skeptics. Get out there and spread the word. Let people know these are coming. And when they start appearing, start helping people understand the technology. There's going to be a lot of fake news based on fake videos. It's just a question of when. One last thing before we start. As I announced last week on the show, we're looking for an intern. I've put up a few details at the dataskeptic.com blog, so check that out. We received a couple entries this week. I have not yet sent thank yous for applying. Everyone's going to get a confirmation, and we're going to make a decision probably around October 1st or so. At least that's when we'll start reviewing things. So you've got till the end of the month to get that in.
My first name is Sui, last name is Liu. I'm an associate professor at the Computer Science Department, College of Engineering and Applied Science, University at Albany State University of New York.
I was very eager to talk with you on the show once I discovered your research on detecting fake videos, specifically these deep fakes. But before we get into the detection, would you mind giving us a definition? What are deep fakes?
Deepfake is a family of recently developed AI-based technology to synthesize videos. In particular, synthesize videos in which the faces in those videos are replaced with some synthesized faces of another person. You can think about the algorithm of deepfake as a translation system, automatic translation system. If we have a translation software or like Google Translate, we input a sentence in English, and on the other side of the algorithm, it will output a sentence in, for instance, Chinese. And the two sentences share the same underlying message, but differ in the representation, in this case, English and Chinese, they are being expressed. Similarly, this is an analogy for deepfake, where you can think about the facial expression, all the movements on facial movements are like the underlying language, underlying message. And then the faces of different people corresponding to different language that we are going to use to express those messages. So what deepfake does is taking one person's face, extract the messages, in this case, facial expressions and movements, and then translate the same message into another language, in this case, another person's face. At the very end, we got a video as if the person whose face are synthesized is actually making those facial expressions and emotions.
One interesting use case for this would be, in Hollywood. You have some very expensive, high-paid actor or actress, and maybe even the insurance company wouldn't want them doing a stunt, or you don't want the risk. You can get the stunt person and then literally graft the actor or actress's face onto the other body. But I get the sense there's some more nefarious use cases for this. What are some of those circumstances?
Well, I think in general, what really concerns people is the ability or was it the capacity of this kind of technology to replace human faces in an arbitrary and low cost way. Let's take one step back. Replacing faces or face swapping exists a long time ago, but what differed back then was to be able to do that, someone needs a lot of training, a lot of understanding of what is happening, how to understand the human autonomy, and also all the softwares, how to use the editing softwares. What has been changed is the fact that this deepfake technology become fully automatic. What you need to make those fake videos are just many, many images of somebody's face you want to replace, and many, many images of somebody's face you want to use to replace that previous person's face. And this piece of software and the computer powerful enough with graphical processing unit or GPU in it. So this lowered the threshold, technical threshold for anybody to make such kind of videos. The examples of misuse of this technology that people have most concern with are anything related with privacy. For instance, you can replace somebody's face with some other people's face as if that person is actually present in the previous scene. One good case example are some of the first round of deepfake videos propagated on the internet, on YouTube, and some other places are pornographic videos where they actually replace the face in the original video with those of some famous actress or actors or actress. This is an infringement of that person's identity, right on identity, and also generating this kind of fake media problem, pornographic videos. It's also by itself problematic. More seriously, people also use this for what we'll call revenge pornography, is to defame someone. There are cases we know about where after boyfriends, girlfriends break up, they actually make this kind of videos replacing the face with the actual person they want to defame and post this kind of videos on the YouTube, on internet, to platforms like YouTube, and then with the purpose of defaming that person. That is, I would say, more serious use of these kind of videos. Now, at a higher level, with the midterm election pending in November, there are a lot of speculations that people may also be able to use this technology to generate fake videos with political intent. For instance, one particular politician hold one type of political view, and then somebody may actually make a fake video putting his or her face into a video that is on an opposite political view, something like that, and propagate that on the internet. That will cause confusion and cause a lot of problems. So those are I would say, one of the serious negative, impactful use cases of this line of technology.
So obviously the deep in deepfakes applies to deep learning, and while this is a skill set many people have, many listeners in fact, not everyone can use TensorFlow. It's a rather new and advanced technology. What does it take to operate the software package you were mentioning? Can someone who knows Photoshop use it?
This is one big reason make deepfake a serious concern right now. You don't even need to know at the level of Photoshop. Photoshop is actually a quite complicated piece of software. For this deepfake, there was early this year, there was a implementation of this deepfake technology in the form of a simple computer program called Fake App. So what do you do as an ordinary user? What the user needs is a computer that is powerful enough. So that computer is maybe the biggest bottleneck at this point because it's not an ordinary computer, desktop computer or laptop. It is a computer with a special computing unit called GPU, graphical processing unit. And that computer is, relatively speaking, still on the higher end of cost to purchase. But with that computer and also getting many, many images of the two people we wish to swap faces in the video, then it's only a matter of typing a command, start training the model, and then once the model is being trained, you can use the model to generate the fake videos. Once we have all this set up and canned into a piece of software, for the user, it's largely automatic. All we need to do is basically getting these images, putting all the images under one folder and run this algorithm, let it know where the training data is. let it run for some time. In this case, to get a really good model, you probably need at least to the minimum a couple of thousands of good high quality face images. And this computer and let it run probably for a couple hours, maybe days, and get this model. Once you have this model, you just input an image or video of the person whose face we want to replace with the one we trained, and it will run for, relatively speaking, short period of time, maybe half an hour, and you get a piece of video generated for you. The burden is mostly on waiting for the results to come out, other than a deeper level of technology or technical understanding of the whole process.
So there are definitely many legitimate uses for this technology, and maybe even some, questionable usage that sort of fall under First Amendment rights. But certainly there are some cases that we just don't accept and we want to get rid of that, the major video platforms would want to filter out. Now, they've been doing filtering like that for a while. Why isn't their current filtering technology adequate?
Well, I think part of the reason is this is a relatively speaking very new problem. All those filters has not really been designed to deal with this emerging problem. So I think that's one major cause. The other is the fact that these are the kind of images that are synthesized in a faked in a different way, right? So it's not purely nudity. These are real human faces. Overall, it's not. Probably nothing could be found wrong. So that's why we need a new set of technology to detect this kind of fake videos.
Well, with that in mind, let's get started discussing your research. How did you go about finding methods for detecting these types of videos?
This is posing a new challenge to the field I'm working in, which generally is known as digital media forensics. The purpose of this research field is basically finding cues and technologies to reveal or expose this kind of fake media. The AI-generated fake media has a very different nature from what we traditionally deal with, are mostly, as you have mentioned, people Photoshop an image. At least those sources of those images coming from existing images, existing photographs. In this deepfake synthesized videos, they are completely hallucinated or generated by an AI algorithm. So what we are looking for, we call the Achilles heel of this powerful AI algorithm behind the synthesis of this kind of video. So they're very powerful, but they also have their weakness. One weakness we spotted, which is summarized in the paper we published last month, is a very simple cue. The first time we know about this problem of deepfake videos is in January this year. So after that, we got interested, and the first thing we would like to do is actually get a piece of the software or the algorithm implementing the synthesizer process. And then we start to making some fake videos ourselves to understand the generation process and to discover and observe some cues that potentially can be used for their detection. So we generate close to 50 different sequences of fake videos, and we start to observe them. And we try something quite simple. None of them actually work well. But we do get a lot of experience staring at those videos. Each time I look at those videos, I always get this strange feeling that they're not right. Looking at those videos make me feel uncomfortable. Just one day after watching at them for almost an hour, I realized what is making me get that feeling. It is that people in those videos, they don't seem to blink as much as a real human do. And the uncomfortable feeling coming from my early experience, when I was young, working with, playing with my friend, we have staring tasks. We stare at each other to see who can hold without blinking for the longest time. And that's when I feel, it's a very strange and kind of eerie feeling. The first time we noticed this, I said this may mostly likely a sort of coincidental thing, and we should check all the videos we have. So we go back and check all the videos. Again, blinking seemed to be largely lacking from all those videos. And we also check some of the videos other people use similar algorithms, synthesize and put public on YouTube or some other video portals, and the same trends seem to hold. So we go back and ask ourselves, what is happening? Why we don't see blinking in those videos? And then we figure out probably one of the important reasons for that. This come back to my early point, how a neural network learn to do something. Neural network learn anything by repetition. by supervision, right? Like, again, taking the analogy of the baby learning to recognize objects, we need to give her a lot of training data, images, objects of the apple, and tell her this is an apple. However, the neural network, like in this case, like a very young baby, is very much limited to what the training data we gave them to understand the world. If we only tell the baby to recognize objects like apples, we show her a lot of images of apples, objects of apples. We never even mention the existence of something known as oranges. Then one day when we actually show her a picture of an orange, she will be very much confused and she may call this as a yellow apple because she simply haven't ever seen this concept. And the data we gave her is in some sense biased because it doesn't include that new concept. So the same thing happened for this deep fake algorithm generating fake videos.
Listeners, let's get serious for a minute. Are you backed up? I mean, are you really backed up? Do you have redundant off-site backups or not? You don't? Are you kidding me? Guys, it's 2018. It's time you were backed up to the cloud. One of the best deals out there that I've come across is Backblaze. They have unlimited cloud backups for Mac and PC for $5 a month. You got to sign up for this before they figure out that this is not a great deal for them. You cannot beat $5 a month, unlimited backups. So have you heard of Backblaze before? Well, they've backed up 600 petabytes so far, and that's growing. Their system is easy. It does the backups for you. Like I said, Windows or PC. All your data gets backed up automatically by default. No picking and choosing or configuration. Guys, this is just like an insurance policy. You can't afford to lose your data. If you're not backed up or you're looking for an alternative solution, head to backblaze.com/dataskeptic. Backblaze is gimmick-free. There's no additional charge. It's $5 a month for unlimited storage and full backups. Try Backblaze by getting a full-featured 15-day free trial at Backblaze, backblaze.com/dataskeptic.
As I mentioned early on, the way we're generating those face images are by giving a lot of face images of real person and let the algorithm figure out how to represent them. However, where do we actually get all those images? Suppose I want to swap faces of two person. We need, at least a couple of thousands of images of both. Where do we get those images? These days, it's very simple. The answer is, just Google them, right? So we type in a keyword, say, some person's name. We use Google. We can get, many images. But there's also a problem with all those images. We actually see that when you actually put a keyword, somebody's name, you get all those images. They all seem to have their eyes open. So when we're actually collecting training data and all this photograph with the subject's eyes open, it's almost like we show the baby all images of apples and never show her an orange. And in this case, the neural networks simply have no idea that humans' eyes can be closed. So this is exactly the reason when we actually synthesize, when generating those fake videos, when humans will naturally blink, will close their eyes during blinking, the neural network has no such conception and will just synthesize images with eyes open and be as similar as a closed eye. Once we have that piece of intuition, we design another neural network. This one specifically targeting the state of openness of an eye. Its whole aim is to differentiate between an open eye and a closed eye. So using this trained neural network, we can detect an eye blinking motion in a video. For a video longer than, say, 5 seconds, and we never see a blinking occur there, that is very, very abnormal for a real person. We also dig into a little bit of literature in physiology. A normal human being blinks every 2 to 10 seconds. With fairly long time without any blinking, that just simply not very likely. So this is one of the simple techniques to detect those deepfake videos. In general, this work leads to a more generic detection methodology, which is looking into the difference between what we call physiological signals. And this comes from the fundamental difference of the deepfake generated videos that they do not come from real humans, right? And real humans have those physiological signals, such as eye blinking, breathing, heart beating, and all those micro expressions on faces while we're speaking. And those things are probably, number one, difficult to represent in training data. Number two, very hard to capture by the machine learning software. So this is the direction we hope that can provide us effective technologies to differentiate the real video and the deepfake generated videos.
Yeah, so this blink approach makes sense to me, and it's very novel and very plausible that you could build a machine learning system to detect that. What sort of metrics do you have to describe the success level of the work?
We use a set of metrics basically judging the classification accuracy of the video being real or fake. So on our own training data, we get almost perfect detection. On our own data, we got like a 99% of accuracy. So we also participate in a challenge sponsored by DARPA, which is the research branch of the defense. This year in June, they have a challenge on differentiating AI-generated videos, digital media videos and images. We participate that using a similar algorithm. We also get one of the top performance of that detection. Our detection rate is about 92%, focusing on human faces. 90% of accuracy detecting if this video is a real video or this is actually generated by this deepfake algorithm.
So if I were a forger and I wanted to make some improvements to the deepfake software and I want to overcome this blinking issue, that appears, as you said, because of a selection bias that humans have in the way we generate photographs or at least share them. But we don't edit blinks out of videos. Could we switch to video for our training data and overcome this?
That's a very good point. Actually, they already started doing that. They started doing that. Interestingly, our paper was put online on this online research portal known as Archive in early June. And only about 3 weeks after our paper is there, I got anonymous emails from anonymous hackers sending me links of videos they generated that claim to have blinking motion there, even though the first round of those fix doesn't work very well. As we work on the forensic side, we also want to keep a little edge ahead of the forgery generators. In my lab, we also ourselves sort of proactively study countermeasures to our detection. We tried exactly what you suggested, using videos instead of single images as training data. And indeed, the algorithm with some tweaks, the deepfake algorithm can generate videos with natural eye blinkings. So that being said, I think eye blinking is a very simple, even though very intuitive, but it's still very simple cue for detecting these kind of videos. So I think with the forgery makers, we're actually playing a cat and mouse game. Knowing the way we detect those fake videos, we improve their algorithm. And on our side, we also working very hard to getting better detection techniques. Currently in my lab, we're trying several other ways to detect deepfake videos. And some of them seem to be pretty promising. So we're preparing some write-ups for those techniques.
Oh, interesting. Anything you care to share, or is there some concern that those same forgers might just need another 3 weeks to overcome the next novel idea?
Well, this is what I mentioned is the what we call the Achilles heel of the deep learning models. As we going deeper into more fundamental problems with more fundamental weakness of those deepfake models, we believe the chance they get some easy fix, like in the blinking case, will be smaller. One of the techniques we're working on, which is in a manuscript we're preparing, is focusing on the resolution differences of the fake faces being generated. Just need to go back a little bit detail of how the deepfake videos are generated. The neural network generating those, they're still limited by the current computation power. Even though I mentioned, you should get to generating this kind of videos, we should get a computer with powerful CPUs and powerful GPUs. These are high-end computers for the commercial consumer level. But still, the computation capacity is not sufficient for generating high-resolution synthesized face images. So what the algorithm ends up doing is generating face images with lower resolution and then resize those images to feed the original resolution in the original video they want to replace face with. And also subjected those images with some geometric transforms to fit the orientation of the faces and different lighting. Those all leave certain, I would say, distinct characteristics in those images. So we have tried recently a method that's specifically looking for those artifacts in images, in face images. And that seems to be also very reliable, and it's not very easy to fix as in the case of blinking.
Yeah, I've had a very similar experience. I've watched a couple of these videos and there's something very uncomfortable and kind of uncanny about them. They're just not right. I can't quite put my finger on, the exact objections I have in every case, but I can definitely detect that they're fakes. So that tells me that the information content is there. I can recognize it, therefore a machine can be built that will recognize it, even if we don't know how to build that yet. Do you think that this is ultimately a losing battle? Are we eventually going to produce a machine so good it's producing results that are indistinguishable?
For digital media forensics, our goal here is not to completely eliminate fake media. I don't think that's possible. What we're trying to do here is just that, for someone to actually want to create a high quality fake video, they need to put in sufficient amount of time, effort, as an investment together with the software for that. So that being said, I believe if a video completely generated by a piece of software and a machine learning algorithm, then there's always a chance that we can detect the difference. This is based on the fact that fundamentally those videos come from a very different source. They're not taken by a camera of an actual person acting. They're actually getting hallucinated by a neural network or some other machine learning models for those images. So this fundamental difference will determine that some traces will be left in those images or videos that an algorithm can pick it up. I'm optimistic that we will have detection algorithm for this kind of fake media. There always this small set of cases where much heavier manual post-processing was put in to make those beat all the automatic detection algorithm we have. On the other hand, I think it's very hard to say which side will be winning eventually because this is like a cat and mouse game. The forgery maker are getting better by understanding how we detect the fake videos and improve their algorithm, and we do the same by studying their synthesized algorithm and finding more weakness to attack. I think this is an ongoing competition and probably will never. At least in the near future, I don't see an end of this. It's not clear who's gonna win ultimately on this battle.
Yes, it's very interesting times we're in for sure. Well, detection is quite important because we really need that for news media to determine, what things are truthful and which aren't. But as you said, there are lots of reasons to produce videos like this and develop the technology. What industries do you see adopting these things first?
I will say the movie industry will definitely be the first, as I think we have seen some movies this year using a similar technology, not complete AI generated yet, with a lot of manual post-processing, but actually replace actor or actress faces into the final produced movie. Or in the case to actually show a movie as if the actor or actress was shot when they were young. That's difficult to achieve using conventional existing technologies. But this kind of AI-aided technology will definitely benefit that kind of business. And video games, I think also, there are already people using this kind of technology to synthesize scenes for video games. But I would say, probably within the next 2-3 years, a large part of what is now in the research community will become mainstream on consumer market, thanks to the fast development of the hardware architectures. With the cost of the GPUs and CPUs reduced and their computation capacity increasing, I'm seeing this on the corner of the street.
Well, Sway, thank you again for taking the time to come on the show and talk about your research. If people wanted to learn more about it or about digital forensics in general, do you have any recommendations?
There are a couple of venues they can actually look for research in terms of digital media forensics. One place is a journal, is an IEEE transaction information forensics and security. I'm an associate editor of that transaction. And there is also a workshop, international workshop on information forensics and security called WIFS. The paper on eye blinking detection of deepfake video using eye blinking. Our paper is published there, and the workshop is actually in December this year in Hong Kong. And these are, I think, tactical venues. People are interested in this kind of technical issues. They can actually go for these journals and the conferences to look for some information.
Thanks for listening to Data Skeptic, where the news may be fake, but the data doesn't lie. Show your support by getting a t-shirt at dataskeptic.com.